So our next speaker is Stefan Wolfsheimer and Claudio Cacciari of Surf. And they're going to be talking about pluggable authentication workflows in iRODS.
Yeah, thank you very much. Yeah, we basically continue what Ellen announced. Yeah, what Ellen announced this morning. So the iRODS consortium has developed or improved the authentication framework, and now we will illustrate one example how we can make use of that. And yeah, this was a project we were working on since 2 years or so, together with SURF, the iRODS consortium, and other parties. And yeah. So SURF is, I give a brief introduction what we are doing. We are a corporation for education and research. We are helping researchers with IT challenges. And in particular, we are interested in supporting and enabling data management. And yeah, we are offering iRODS hosting. That means we have set up a bunch of iRODS instances on our cluster, and researchers can use that to implement their iRODS, their data management workflows and automation. And yeah, we face some challenges. One is that users want to bring their own identity from their institutes with and authenticate against iRODS with their identities and groups from their institutes. This is in particular interesting when you want to collaborate in a team. Where, yeah, and another yeah, another challenge is enabling multi-factor authentication, which is not directly supported by iRODS. So for sensitive data, we might need to have additional security. And yeah, this is a typical workflow. So there's a user, the user logs in or wants to use iRODS. The user is sent back to the identity provider of the institute. The user enters his or her credentials and gets a token back, which he can use to log in against iRODS. I think Claudio had presented this 2 years ago or a year ago at the user group meeting. If you want to see the details of this specific workflow, you can get the slides and or talk to us. And yeah, iRODS already supports some authentication methods like native authentication, that is just a username and password that is stored in the iRODS database, but it has various others like PAM, OIDC, which I learned today is not maintained, which the code is there, but it's not maintained. And the question arises why we need additional methods. Yeah, when we try to implement the workflows, we realize that the current implementation of the PAM authentication plugin or the native is restricted to username password only. So that means if you need a second factor, there is no way to enter a second factor for second factor authentication. And we try to extend the possibilities a bit towards a more flexible way of challenging the user with passwords and second factors. I will illustrate that in a moment, what that means. So we have decided to use PAM because PAM is already flexible. And here we see a typical use workflow for PAM on the right side. So you see this state diagram or decision diagram. The user logs in, enters credentials. The credentials are validated, and on failure, it failed. And if it's successful, the user is challenged with the second factor. And then at the end, he or she's authenticated if that was successful. And the second part is already not directly supported by the present iRODS plugins for authentication, because there's the assumption that the user only enters username and password. But PAM itself does support such workflows. PAM is quite flexible. You can implement any workflow you would like with PAM. And there are three typical roles: system administrators, so people who basically define such workflows here, so they can pick and choose from different modules and combine them to implement any arbitrary flow. Then there's application developers. They need to make sure that the application actually supports PAM. And module developers. Module developers develop modules from which system administrators can choose to define their workflow. For example, you can think of a PAM module that just checks username and password against a user database, or more complex scenarios where you check against web services. Yeah. And yeah, we will illustrate that in a live demo. This is already one example, which is based on a PAM module called PAM Python. PAM Python is basically a link between the PAM library and Python, which means that you can easily prototype and develop your own workflow in Python instead of C, so you can make faster progress. Not sure if I would recommend to use that in production, but for prototyping, this is really a nice way, and that's why we also decided to use the demo here, to use it in the demo here. We mimic a user database with 2 users, very unsecure password. And what you need to do when you want to use PAM Python, you basically need to implement this function here, which takes the user input and returns success or error, depending if it's wrong or right. And we just check if the user exists and the password is correct. So this would also work with the existing PAM. With the no, I don't want to enter smileys now. How do I? Sorry, escape. Did I enter escape? What did I?
You can move it over here.
Yeah, let's
Just leave it.
it's okay,
Okay.
then it's not so disturbing. Where I am.
You should click in the.
Yeah. Yeah. Okay. Cool. Thanks. And yeah, below we basically see a typical PAM configuration. You can. Yeah, it's usually executed from top to bottom, and required means that this particular rule that is defined in that line is required to log in. And simple Py is just the Python script I have shown in the previous slide. So it just checks the user credentials, and I don't want to confuse you. Yeah, we now do init. And this is now driven by the new plugin. Ayub is a default value because I previously went through that flow with that username. You can override the default values here. And password is super secure PW. And now we are logged in. And we can do ILS as usual. Nothing fancy so far because this is already supported by the existing PAM module, PAM plugin. Now we want to go. Other questions so far? Maybe we can go further and enable the second factor. So there's now both modules need to be fulfilled and exit with success. And this is probably here, the next slide. This is the implementation of the second factor. So yeah, it's just a sketch. So of course, in real applications, you do not just compare against a constant hard-coded number, but it should illustrate what we are doing. So we displaying a message to the user, enter PIN, and this is sent back to the client, and it's waiting for the user input and getting some response back. And in case it is 1, 2, 3, 4, then we go further. And here we have already new features that are implemented in that version, which is not available in present version. So we generate a random number, a random token, and instruct the PAM plugin to store the value of that token locally at the user's home directory. So this could be, for example, an ORDC token, or yeah, something that you want to retrieve later on in another cycle. I show in the next example, I show how to retrieve this data. Yeah, and if the PIN is correct, the token is saved, success, otherwise error. And let's check it, how it is in action. Again, username. The system is aware that I've used that username before. Password is cached. Oh, I previously added, yeah, I should have cleared my old data from tests, but usually it should not, the default value should not be presented here. And now we are logged in with a second factor. Yeah. No, yeah, now we are logged in. We can do whatever we want. It's now, it has generated a temporary password in iRODS, which is valid for 1 hour. And after 1 hour, it will go again automatically through the PAM stack without the user notifying it. Yeah. Should we increase the complexity one step further? So this is the third layer. Echo, what does that do?
The letter B. Did the letter B at the beginning of that third line? Is that on purpose?
Letter. It was an accident, I guess. I will correct it then.
Oh.
So we now using basically the token to authenticate that has been stored to the user, to the user's home directory. So here we save the token in the first step. And then later on, we want to retrieve it. We have stored that under that path in a JSON document. And we have a function that checks that token and returns success or error. Yeah. Oh, actually, that's not exactly what. Yeah, that was B. That's not exactly. Slightly different. Yeah, slightly different workflow, but here I wanted to show how to retrieve the token locally and do something with it. Yeah, it's slightly less complex. So you get the token from the local cache and prompt it to the user. Yeah. Yeah, that's basically the extension that we have. How much time do I have left?
Oh, we have 3 minutes. We have 3 minutes.
Okay, then
Quick question.
questions.
Yeah.
Yeah.
So in the token, the assignment of that random string that gets created, does that stay just in cache? It's not stored in a database for any period of time, is it?
It's stored locally at in the user's home directory in a JSON document.
Okay.
Yeah.
Okay.
Yeah. So there's no additional database or table or anything involved here for that. Not yet. So one needs basically extend all clients. It's not supported automatically. Actually, we needed to patch init a bit. Yeah, but it was only one iCommand function. Also, this also applies for the Java clients. Yeah. Go.
All right. Are there any other questions? All right. Well, thank you, Stefan.
Thank you.